Hello, my esteemed viewers. You're welcome to Medical Science Lecture Room. Today, I'll be discussing with you on the topic perpendicular vectors. Just to remind you, I have done videos on parallel vectors and scalars. But today, I would like to discuss perpendicular vectors. First, you need to know what perpendicular vectors are. Two vectors are said to be perpendicular if they run into each other such that an angle of 90 degrees is formed between them. For instance, if I have a vector that runs this way, supposing this is a vector, let's say this vector is vector A, and it's going this direction. Remember that a vector must have magnitude and direction. So let's say that this is the direction of vector A and this is the magnitude. VA is the magnitude of vector A. Now, supposing vector A runs this way and then you have vector B going this way, such that vector B meets vector A at a point, making an angle of what? 90 degrees. Remember that when an angle is formed when two lines meet. So this is what the A represent one of the line, and then B, that is the second line. Of course, this is a vector, which is why I've indicated this as the direction. This is the direction of this vector. Why this represents the direction of this vector? They both are going different direction, but they have met at a point. And because the meeting point gives us an angle of 90 degrees, we now say that these two vectors constitute what we call the perpendicular system of vectors. I did say in my previous videos that once you have a problem, a vector question or a vector problem, the first thing you need to know, you have to ask yourself, what system of vectors are you dealing with? Is it perpendicular vectors? Is it parallel vector? Is it inclined vectors? So in this case, it is perpendicular vectors. I repeat again, what makes it perpendicular vector is because the two vectors are meeting at a point such that an angle of 90 degrees is formed between them. So now, if this is the two vectors, and somebody now asks you, calculate the resultant of these two vectors. Again, this is vector A, the magnitude is VA, and this is vector B, the magnitude is VB. Now, remember that a vector must have a magnitude and its a direction. So this vector has this magnitude and this is its direction. This vector has this magnitude and this is its direction. So how do we go about looking for what? The resultant of this vector. Quickly, you have to apply the law of parallelogram in this case. Now, how do we achieve that? This is not a parallelogram. So for us to apply the law of parallelogram, I need to ensure that this becomes what? A parallelogram. And how do I do that? I will construct a line here. I will construct a line there and then construct another line here. Why am I doing that? It's because a parallelogram is a four-sided shape. So I need to have a four-sided shape or figure, which is why I have drawn this line. I've constructed or assumed I've constructed this line, and I've also done the same here. And once you have done so, you now have a four-sided what? Figure. And I haven't done so. I will now take this line to be what? The direction or the side of what that represent my resultant. So according to the parallelogram law, if you have a four-sided figure, a four-sided shape, and of course this will be a diagonal and this will be also a diagonal. But according to the parallelogram law, this diagonal should represent what? The resultant. And so I now have this diagonal representing my resultant. And so if this line is drawn here, you know that for a four-side parallelogram, opposite sides are equal. Therefore, if here is VB, here must also be what? VB. If here is VA, here will also want V1A. So we now have two triangles. We have two triangles, this triangle and this triangle. You may decide to use one of them. So if I decide to remove this triangle, I will have something like this. This is VA, this is VB, and this is what? R. you can see. Now from here, of course, here will be what? 90 degrees. Here is 90 degrees. And what does this tell us? That this is what? A right angle triangle. And if it's a right angle triangle, I would therefore apply the Pythagoras theorem to get what? The resultant. And by Pythagoras, I would say that the square of what? The resultant, which is this line, must be equal to the square of VA plus the square of what? VB. That's according to Pythagoras. Because Pythagoras says when you have a right angle triangle, the square of the hypotenuse, which is the longest side, must be equal to the square of the sum of the other two opposite sides. So if this is the longest side, which is what? My hypotenuse, the square of that side must be equal to the square of this side plus the square of this side. And that's why what we have here. So of course, if we go ahead to find the resultant, because then this R will therefore be equal to the square root of what? VA square plus VB square. Remember, where VA and VB refers to what? The magnitude of vector A, and this is the magnitude of what? Vector B. So this is a case of what? The perpendicular vector. What makes it perpendicular vector is because there is an angle of 90 degrees that is formed between the two given vectors. Again, this formula only tells us how to find what? The resultant. What about the direction? Remember that this resultant is a vector, and if it's a vector, it needs to have what? Its magnitude, and it also needs to have what? Its direction. So having done this, having applied Pythagoras theorem, what you have gotten will be what? The magnitude. Therefore, how do you get the direction? For you to get the direction of the resultant, I will be looking at what? The angle the resultant makes with VA. Let me say that angle, let it be theta. Or the angle the resultant makes with the vector B. Let's say that angle is what? Alpha. So if one person is calculating this angle as the direction of the resultant, another person may be calculating this angle as the direction of the resultant. But what is important is any of the angles you calculate, you must be able to state the location of that angle. If I calculate for theta, I should be able to say that the angle, I should be able to say the direction of the resultant is, if it's 30 degrees that theta represent, I should be able to say the direction of the resultant is 30 degrees with vector A. So if it is this one I have calculated and I found it to be 40 degrees, I should be able to say that the resultant of what? The resultant is 40 degrees with vector B. So there has to be emphasis to the direction or the position of that angle. If not, you won't be, have it right. So that is how. So what do we do? If I want to find theta, I will simply say tan theta is equal to opposite. Of course, tan theta will be opposite all over what? Hypotenuse. Why am I applying that? Because this is a right angle triangle. So you have every right to apply what? Your trig ratios, your trigonometric ratios, which of course it's we have them as sine, tan, and cos. So if I'm applying tan, why am I applying tan? Because I know this side is given and this side is given. So I will say VB, which is the magnitude of the vector B, all over the magnitude of vector A. And so that will be what? If I go ahead to find theta, I mean theta itself, of course, you know, that will be equal to arctan V all over what? VA. And once you do that, whatever you have becomes what? The direction of what? The resultant. When someone is doing that, another person may decide to calculate this instead. If you are calculating for this, again, you know that this will be what? This over this. Again, I can say that tan alpha is equal to, in this case, opposite. This A is facing alpha. Therefore, the VA in this case represent the opposite. And that will be what? VA all over the adjacent. The adjacent has to be this other line, and that will be what? VB. If you go ahead to find your alpha, this will be equal to arctan VA all over what? VB. And so at the end, with that, you must have had what? The direction of what? The resultant, as well as what? The resultant of what? The magnitude of what? The resultant. Let's take an example. Let's take an example for you to have understanding of what perpendicular vectors is. Let's consider this. We said we've been given this question. Given two vectors A and B, A is due east of a town P, B is due south of P. If A is 4 kilometers and B is 3 kilometers, find the resultant. Now quickly, let's react to that question. For you to, the first thing you have to do, you have to draw your cardinal point. And now we've been told that there are two vectors A and B. And the two vectors, the first vector is vector A. The third vector A is due east of a town. Is due east of a town P. Now that means, let's take this point to be what? The town. And A is due east of this town. So it means that the A vector goes this way. So that is the direction. And we've been told that the A vector is 4 kilometers. Now the same vector B is due south of P. Now this is vector B due south of P. And we're told that the kilometer is 3. This is 3 kilometers. This is B vector, while this is A vector. So this is simply the diagram. Vector A is due east of a town P. Vector B is due south. Due south, of course, here will be north, south, east, and west. Due east means that the vector maintains the eastern direction. Due south means that vector goes in the southern direction. So if this is the meeting point, which represents what? The town P, we've been told that vector A, vector A's direction is due east of P. And so which is why I have drawn this line in the eastern direction. And vector B is due south of vector of the town P. I have drawn equally this vector from telling you that B is due south of what? Of the town P. And now this becomes the diagram. And now what do I supposed to do at this point? I will try to make sure that this becomes what? A four-sided diagram, a four-sided shape. And that's by what? I'll construct a line here and then construct another line here. And I haven't done so. You now see that we have a four-sided shape. Now with this, I will say that this diagonal, of course, from here to here, if I draw a line from here to here, that line becomes a diagonal. If you draw another line this way, that's a diagonal. But according to the parallelogram law, this diagonal is always described as a leading diagonal. That will be what will represent what? The resultant. And so my resultant, this line becomes my resultant. And with that, 3 kilometers here will be the same here, 3 kilometers. Remember that a four-sided shape or a parallelogram, opposite sides are always what? Equal. Therefore, if here is 3 kilometers, here must equally be what? 3 kilometers. And if here is 4 kilometers, here will be what? 4 kilometers. Now, we now have what? Of course, at this point, we have two triangles. We can take out this one or you take off this one. Whichever one, you will have the answers correct. So if I remove this triangle, I will have something like this. Where here is 4 kilometers and this is 3 kilometers. And of course, here will be what? The resultant. That will be the resultant. And then I will now apply the parallelogram, the Pythagoras theorem. Remember that the square of the hypotenuse will be equal to the square of the other opposite side. So here will be 4 kilometers square plus 3 kilometers square. Of course, this will be 16 kilometers square minus 9 kilometers square. Of course, R will be equal to, R square will be equal to that. You now say 16 minus 9. 16, sorry, this is plus. You now say 16 plus 9. Of course, that will give us what? 25 kilometers square. Now, we said R is equal to the square root of 25 kilometers square. Of course, that will be what? 5 kilometers. So it's now clear that the resultant has the magnitude 5 kilometers. But remember, we need to find its direction. I told you earlier that the direction can either be the angle here or the angle this way. So if we decide to calculate this angle, we can now say tan theta is equal to opposite. Opposite will be, that will be 3 all over the adjacent. The adjacent will be what? 3 kilometers all over 4 kilometers. if you want the direction of this resultant, remember the resultant is equal to 5 kilometers. And if we want its direction, we will say that tan theta is equal to 3, which is opposite all over adjacent. And so when we do that, this will now give us, tan theta equal to 0.75. We'll now say theta is equal to arctan 0.75. And once you do arctan 0.75, that will give you the direction, the angle, which represent that angle will be what? The angle theta. And that will be the direction of the resultant with what? The 4 kilometer word vector. So the idea is that once equation is given to you, try to have that question, if it's given like here, it is given in words. So what you need to do, you have to interpret it. It will now give you what a shape like this, a diagram. From that diagram, you should be able to say whether what you have is a parallel vector or inclined vector or perpendicular vector. Remember that I told you, for you to solve any problem that regards regarding vectors, you should ask yourself what you are given. Is it parallel vectors? Is it perpendicular vector? Is it inclined vector? For each of them, I told you how to recognize it. For parallel vectors, I told you, I did a video on parallel vectors. I told you when to know that the vectors are said to be parallel. Like today now, I have told you how to know that the vector is perpendicular. I say when there is an angle of 90 degrees formed between the given vectors, that is when you say that vector, what you have is a perpendicular vector, and what you do to that is to apply the Pythagoras theorem to enable you get the resultant, and then you further apply your trigonometric ratios to find what the direction. Now, if it is an inclined vector, it's a different thing. For inclined vector, you're going to apply what? The trig ratio, your cosine rule and your sine rule. So I want to believe you have understanding of perpendicular vectors. So in case you have any question, please drop them at the comment section. Again, do not fail to like this video. So also subscribe to this channel. Also to remind you that you have to go for other videos of vectors. I've equally done videos for other topics of your physics, chemistry, and mathematics. Also to remind you, we also offer medical education to our viewers, even at the comfort of their living room. Thank you.